Hello guys, in this video we will work on this problem from 2021. इस प्रॉब्लम में एक प्रोजेक्टाइल है which will split in two parts at the highest point. So हम प्रोजेक्टाइल मोशन अप्लाई करेंगे एंड मोमेंटम अप्लाई करेंगे. बट बिफोर वी गो इनटू स्टेप बाय स्टेप सॉल्यूशन, आपको ये समझना होगा कि मोस्ट स्टूडेंट्स they lose points in the very starting even before they start solving the problem. और दो मेन रीजंस है प्रॉब्लम को मिसरीड करना या कोई कॉन्सेप्चुअल मिस्टेक कर देना इन द बिगनिंग. जैसे कि मिसरीडिंग में इफ यू रीड द प्रॉब्लम इट सेज दैट द प्रोजेक्टाइल स्प्लिट्स इन टू इक्वल पार्ट्स और उसमें से एक पार्ट इट फॉल्स वर्टिकली and hits the ground 0.5 seconds after the splitting. एक मिस्टेक होगी कि if you are in rush, आप जल्दी में है and you think this 0.5 second is from the starting, from the moment when you launch the projectile. तो ये keywords जो है after, right, your reference point is very important. Conceptual mistake होगी कि somebody will apply energy conservation. So if you do misreading or conceptual mistake in the starting, उसके बाद आपकी पूरी मैथ सही है, आप इक्वेशंस सही सेटअप करते हैं, बट यू विल लूज 4 पॉइंट्स. सो इस वीडियो में हम क्या देखेंगे? वी आर गोइंग टू सी हाउ टू सिस्टमैटिकली सेटअप द प्रॉब्लम, राइट? कीवर्ड्स, फिर डायग्राम, एंड देन व्हाट आर द स्टेप्स, फेजेस इन द प्रॉब्लम, एंड देन हम पूरे प्रॉब्लम को स्टेप बाय स्टेप सॉल्व करेंगे. एंड आई एम गोइंग टू एक्सप्लेन ईच स्टेप. व्हाई डू यू अप्लाई अ सर्टेन इक्वेशन, व्हाट इज द कॉन्सेप्ट बिहाइंड. सो लेट अस स्टार्ट. In this problem, let us read the problem. It says a projectile is thrown from a point O on the ground at an angle 45 degree from the vertical. So ये जो vertical है, that is a key point that you have to understand from the vertical. इस problem में we are lucky that if by mistake somebody reads the problem and misses this word vertical and आप सोचते हैं कि ये है, it is just luck that your solution will still be right, क्योंकि if horizontal angle 45 है तो vertical भी 45 होगा. But if the problem was 30 degree from vertical, let us say 30 degree from the vertical, right, and कोई अगर ये कर देता है कि 30 degree here, then your entire solution will be wrong and it will cost you 4 points. Okay, then the launch speed is 5 square root 2, right, 45 degree from vertical. These are keywords. Then when the projectile reaches at the highest point, the highest point पे it splits in two equal parts, right? One part falls vertically down to the ground. So one part travels vertically and it hits the ground 0.5 second after the split. Important. Other part travels normally, so it can be any projectile motion, hits the ground t seconds after the split, not from the start, after the split, and it falls on the ground at a distance x from the starting position. तो ये जो x है, this is not horizontal distance from the split but from the launch point. Okay, and the value of gravity is given as 10. We have to find out t and x. So that is reading the problem very carefully. Now second step, हम डायग्राम प्लॉट करेंगे. तो ये कीवर्ड्स है जो कि हमने किए अभी. सो This is the start point here, 0, 0. X is horizontal, Y is vertical, and we launch the projectile with the speed 5 square root 2 at 45 degree from vertical. We launch it, so it will go under gravity. So there is gravity here, right? So it will follow a parabola, and when it reaches the highest point, right? At the highest point, it splits in two equal parts. So time is 0 in the starting. At time t1, which we right now we do not know what is time t1, m reaches the highest point. So this is your highest point. This is your highest point. तो अगर ये m split नहीं होता, so m would have just followed the parabola and continued its motion, right? लेकिन यहां पे m split हो गया in m1 and m2 equal, right? Equal parts. So that's why m will become m by 2 and m by 2. So yellow one is we are calling it part 1, और ये vertically travel करता है. It falls vertically and hits the ground in 0.5 seconds. So यहाँ पे जो time है t2, the time part 1 m1 hits the ground is t2. That t2 is the time t1 when the projectile reaches the highest point plus 0.5. This is important to understand, right? 0.5 is not from the start. The other part 2, hits ground at t seconds after split. So ये जो blue part है m2 m by 2, that follows a projectile motion again and hits the ground at time t3, and that time 3 is time t1 plus t, this t here, right? Because it says after split, t3, right? And it says it hits the ground at distance x from the start point. So this x distance is from the start point, right? So we have the diagram. Now, before we solve it, think about the steps in the problem. So from here, from time 0 to t1, so I'm going to write phase 1 is 0 time to t1, and in that time m travels from 0, 0 to highest point. And then phase 2 है ये moment when m splits into two equal parts. ये splitting moment है, इसको हम कह रहे हैं phase 2, right? So m splits into two parts, m by 2, m by 2. Phase 2 is split. And then phase 3 है when both m1, which is m by 2, and m2, which is also m by 2, they both travel, they fall under gravity, right? So phase 3 है when the time is greater than t1, and phase 2 है time t1, and phase 1 है time less than t1, right? So phase 3 में m1 and m2 travel, right? They travel beyond t1. Next step, अब हम each phase, phases 1, 2 and 3, we are going to solve them in order. हम इन phases को step by step solve करेंगे. Let us look at phase 1, right? This is time less than t1, right? So we are only going to focus on this part here, right? So let's only look at from time 0 to t1. So time less than t1. तो यहां पे जो कॉन्सेप्ट लगेगा that is projectile motion. So before we apply the projectile motion equations, let's have a quick review of projectile motion equations. So when you go to the exam, you must know these formulas and what are the limitations when you can apply these formulas. This is very important. In the exam, you won't have the time to think about what the formulas are, right? You must know them immediately. So projectile motion mein you have xy coordinate, right? And you launch a projectile with launch speed, right? U जो है ये launch speed है, ये launch है at angle theta from the horizontal, right? And then it follows a parabola, projectile motion. So time is 0 at the launch point, 0 0. So let's pick a random time t here, right? This is time t. So at time t, its velocity will be v, which we do not know, right? And it's making an angle of phi from the horizontal, right? So, and the highest point is here. And one thing you must remember, that highest point पे जो vertical speed है वो 0 होगी. That's why it is the highest point. क्योंकि if it is not 0, that means it is still going up or down, right? So highest point पे velocity, the vertical velocity है 0 है, and after that it will start going down, right? तो ये छोटे छोटे जो points अगर आपको याद है, it will be really easy and fast for you in the test. So now, so horizontal जो speed है ux initial, that is u cosine theta, right? The horizontal component. And जो vertical component है वो है uy u sin theta in the starting. At time t, horizontal speed है vx, which is v cosine phi. Phi is the angle the velocity is making at time t, right, from the horizontal. और vy जो है vertical component है. आपको ये भी याद होना चाहिए कि in projectile motion horizontal speed does not change, right? Because gravity is in vertical, there is no acceleration in horizontal direction, right? तो अगर आपको ये याद है तो you will know that vx is equal to ux. So ये जो horizontal component है that does not change. So horizontal direction में speed is constant. So the distance traveled in horizontal direction is just speed multiplied by time. So ये जो x है, this x here, that will just be horizontal speed which is constant throughout the motion multiplied by time. Y direction में you have gravity. So vy जो है ये vertical speed है at any time t, right? And that will be uy, the initial vertical speed minus gravity into time. And the vertical distance जो travel हुई है y, that will be initial vertical speed uy multiplied by time minus half g gravity t square. So ये questions आपको याद होनी चाहिए. Let's go back here. So what we are going to do now, we are going to solve it, right? So first of all, starting में we can find this component, right? This is u. और ये होगा आपका ux and ये होगा u cosine और sin 45, right? तो u जो है 5√2 है and sin 45 is 1/√2, so it is 5 meter per second. तो we know in projectile motion horizontal speed is constant, it does not change. तो अगर हम यहां जाएं, राइट, तो यहां पे m1 की ये जो हाईएस्ट पॉइंट है, दिस इज द हाईएस्ट पॉइंट, हाईएस्ट पॉइंट, ये जो स्पीड है, राइट, दिस इज ऑल्सो 5 meter per second. This will not change. You are here, that will also be 5 meter per second, right? At any point on the trajectory, horizontal is 5 meter per second. And ये highest point है, so आपको ये याद होना चाहिए कि highest point पे vertical will be 0. So basically at this point there is no vertical speed, right? So no vertical speed. So Vy is 0. Vy is 0. Right. Now we can also calculate what is this highest point, this h. And this h is u square sine square theta by 2g. U is the launch velocity and sine theta, right? So let's do that. So h will be u square, right? U square sine square 45, right? Divided by 2g. So u is 5 root 2, right? 5 root 2 square sine square 45 degree divided by 2g. G is 10. So sine 45 is 1 by root 2, right? So it will be 1 by 2. So basically you will have 1.25 meter. So this maximum height, the maximum height है ये है 1.25 meter, right? What is T1? What is T1? So इसके लिए हम यूज कर सकते हैं y डायरेक्शन में Vy equation. What is the vertical speed at the highest point? We know that is 0. So Vy is 0 and we know the initial vertical speed here. So that will give us the time, right? So let's go here. So for T1, we will use vertical direction में Vy equal to Uy minus Gt, right? So again आपको equations याद होनी चाहिए, right? So Vy is 0 and what is Uy? So here यहाँ पे Uy, it will be same as Ux क्योंकि इस problem में theta is 45 degrees, so things get quite easy. So Uy will be U cosine 45 and that will also be 5 meter per second, right? So here you will have 5 minus G is 10 meter per second square T. So that T is T1, right? So यहाँ से हमें मिलेगा T1 जो है, so this will give us T1 is 0.5 seconds, right? So यहाँ पे हमें मिल गया T1 जो है 0.5 seconds, we get it T1, right? And we got highest point, right? Right? Now, what is this distance at the highest point? How far is the object from the launch point? So इसके लिए हम use कर सकते हैं in horizontal direction x is horizontal speed which is constant throughout the projectile motion multiplied by time uxt. So if we go back, so this distance here, this distance will be ux t1, right? And ux is 5 meter per second, so 5 multiplied by t1 we just calculated 0.5, right? So we will have 2.5 meter. So from the start point to highest point, the horizontal distance is 2.5 meter, the vertical distance is 1.25 meter, and the time t1 is 0.5 second, and highest point pe there is no vertical speed, Vy is 0 and m is traveling at 5 meter per second in horizontal direction. And we completed phase 1, right? Now we know all the values in phase 1. So again ये equations आपको याद होनी चाहिए, and this is very important to remember that highest point पे vertical speed 0 होती है and speed does not change in horizontal direction. In horizontal, in vertical it does change. This is vertical, right? Now phase 2. Phase 2 is when the time is t1. Time is at time t1, right? The projectile splits into two equal parts. So ये जो m है, that is traveling at 5 meter per second horizontally, and it explodes and it splits in two equal parts. So this is m1, m by 2, and this is m2, right? Now the question does say something. If you go back here, right, that splits at highest point to equal parts and part 1 falls vertically. So the problem is telling you that m1 does not move horizontally, it just falls vertically, right? So if you go back here, so that's why For M1, we are saying it has a speed Vy1. Now that is another conceptual mistake, that the problem does not say कि after split ये जो part that is falling vertically, that starts at 0 speed, it doesn't say, right? It doesn't say. So we do not know the speed, right? We do not know if it is downward or it can be upward, right? Is it downward or upward? We do not know. So if it is going to be upward, we will get a negative answer, right? But the thing to remember is that do not, I will write it here, do not assume that Vy1 is 0, right? Do not assume Vy1 is 0, right? And after the split, जो M2 part है, जो blue one है, उसके horizontal speed we are calling Vx and vertical we are calling Vy2, right? So question है, what is Vy1, right? What is Vy1, what is Vy2 and what is Vx? तो अब हम देखेंगे concept of momentum conservation. So see, before split, okay, you have the body. Split moment पे क्या होता है? What happens at split? So inside, imagine it's like an explosion, right? So it divides in two parts, right? So this is, let's say, M1 and this is M2. So what you're seeing here is that M1, M2, right? These two forces, right? M1 and these two forces, right? So M1 and M2, they apply equal and opposite, that is Newton's third law, equal and opposite forces on each other, right? So if you look at this entire system, and for this I will recommend you to watch my video for momentum and collision problems. I will post that link in the description for this video. तो उसमें अगर आप देखेंगे तो it is explained that on this system, right, no external impulse of force, right? No external impulse, right? ये जो F1 and F2 है, F जो है ये internal है, this cancels out, F is internal, right? See, yes, there is gravity, right? There is gravity, you have gravity, but the thing is gravity जो है, it is much smaller than this implosion. ये जो implosion है, इसके comparison में this is much smaller, right? So you ignore the impulse by gravity by G during split. और जो ये split है, right, this split, right, this moment, this delta T is approaching to 0, right? It's a very small time, right, like millisecond. So ये जो F है, that is very high force, right? So it creates an impulse, but because this is internal to the system, पूरे system पे कोई external force नहीं है, so we can say momentum of M1 and M2 is conserved, right? So now we go back here. Now what we do, we're going to write momentum conservation, right? Momentum conservation. So first we would write in x direction. We would write in x direction, right? So in x direction, first in x direction, and let's say this is plus, to the right is plus and to the left is minus, right? So before split, not slip, sorry, it's split. before split, right? Momentum before split is going to be after split, right? That is momentum conservation, and that is just before and just after, right? So before split, you have m multiplied by 5, right? We do not know m. Also, you will find out that we do not need to know m, right? And that is equal to m by 2. So you do m1, right? It does not have any horizontal motion because the problem tells us that it falls vertically, right? So I would rather write, so nobody is confused, right, that m1 multiplied by 0 and then plus m2 जो है which is also m by 2, उसकी स्पीड है vx, right? m2 vx. So यहाँ पे हो गया 5m equal to m2 is also m by 2 vx. So we get vx जो है वो हो गया 10 meter per second, right? Because m would cancel out, right? So ये जो vx है, we just found out that this vx here is, this is 10 meter per second. So we solved for this portion here, right, from momentum conservation. So momentum is conserved. We can also apply it in y direction. So let us apply in y direction, right? Now in y direction, so same concept, just like x, right? So let's say, right, this is plus, up is plus and down is negative, right? So before split equal to after split, same thing. So before split, what you have? Before split is 0, because look at before split. M does not have any vertical speed, right? Because it is at the highest point. So speed of vertical speed that is 0. Equal to, so M1 जो है, M1 and Vy1 is downward. So downward we are calling negative. So it will be minus Vy1 and then plus M2. M2 जो है, that is going up with Vy2. So up is plus. So M Vy2. And you will see M1 and M2 are equal. So this will tell you, that Vy1 equal to Vy2. That is what we get. Remember? So M1, M2 again, I will write M1 equal to M2, both are M by 2. That is given in the problem. So यहाँ पे हमें we find out that Vy2 actually is equal to Vy1, but we do not know what is Vy1, right? So in phase 2, that's what we get. We get, okay, after split, the blue part that has a horizontal speed of 10 meter per second. We still do not know what is its vertical speed, and the yellow part है M1, उसकी जो downward speed है Vy1, we also do not know. But we know one thing, that this Vy1 is equal to Vy2. Now, so this was momentum conservation. Now phase 3. Phase 3 is the time is greater than t1, right? So phase 3 is this part here, right? Path of M2 and path of M1, right? So we still do not know what is this value, right? Or Vy1, what is this value? So we are going to use this information. We are going to use this 0.5 second information, and the height is 1.25, right? So let us look at this motion here, this part here. We are going to use this part. So go back to projectile motion equations again, right? In the y direction, the vertical travel, the vertical distance y at any time, right, that can be written as uyt minus half gt square. So let me write that equation here and you will see how we can apply it. So this equation, right, so I will write the equation we are going to apply is y equal to uyt minus half gt square, right? That is the formula, right? But now we set this is for M1, right? We set our 0 0 at highest point, point, right? So if you see, if we set our 0 0 here, then m1, the yellow part, it travels down in negative direction, right? So again, up is positive, down is negative. So we can write this y is minus h, right? This thing here is minus h, right? So to be more precise, I will just write, instead of h, I will write 1.25. 1.25. Y is 1.25, right? And minus is important because in this formula, y positive is up and negative is down. Equal to uy. What is uy? Vy1, right? But again, we draw it downward. So again, if you look at the projectile motion equations, here uy is up, right? Up is positive. So if you go back, so in this one here, uy जो है ये होगा minus vy1, minus vy1. So I will write here, this is vy1, and t, what is time t? This travel time here is 0.5, right? 0.5 is not from the start, but it is from t1, right? So this time here is 0.5. So vy1 multiplied by 0.5 minus half, g is 10, and t is also 0.5 square. And now you will see something very interesting, that you will see that vy1 is 0 here, right? So if you solve it, so this will give us that vy1 is 0, right? So vy1 is 0. So we have 0 here, and therefore vy2 will also be 0, right? So here what we see is that after split, actually m2, m by 2 is traveling horizontally with 10 meter per second. This is 0 and this is also 0, right? So m2 will just follow the parabola and hit the ground. So now we are going to find out the trajectory path of m2, right? So path of m2, right? Now we are going to solve projectile motion. So we are going to solve projectile motion for m2, right? So we are going to solve projectile motion for m2, and then we will have our answers for what is this t value and what is this x value. So let us write projectile motion equations for m2, right? So we know horizontal speed is 10 meter per second, and as you can see मैंने इसको दोबारा draw किया है क्योंकि now we know कि after split m2 does not have any vertical speed, it just only has horizontal, right? So it will just follow this trajectory, right, like you see here. So again, quickly remember what was projectile motion equations, right? One important thing, that speed does not change in x, right? Highest point पे vertical speed 0 है, and y direction में this is the formula. I mean, these are all formulas, right? So what we're going to do, we go back here, and what we know that from here to here m2 travels 1.25 meter in horizontal, right? So let's apply the vertical motion equation, y equal to uyt minus half gt square, and we are going to apply this for m2, right? For m2, for this one, and again up is positive and down is negative, right? So it travels down, right? And when m2 hits the ground, the vertical distance traveled by m2 is 1.25 meter, and that will be negative. So here y will be minus 1.25 equal to What is the vertical speed of m2 in the starting, right? uy. What is uy? Uy is 0, right? And this multiplied by t, right? We are talking about this t here. This is the t we are talking about, right? And then minus half g is 10 meter per second square multiplied by t square, right? So here you will see, if you solve it, you will get t equal to 0.5 seconds. So this t here is 0.5 second. So if we go to our problem, here we are talking about this t here. This is 0.5 seconds. We found 2 points. This is 2 points. So we go back here. We got 0.5 seconds, right? Now we have to find x. So we know from start to the highest point, the horizontal distance is 2.5. So if we find this distance here, right? If we find this, then we can tell what is x, right? So this distance here, for this distance, we can again recall the equations from projectile motion, and horizontal distance x at any time is horizontal speed multiplied by the time. So if we go back here, right, see, horizontal speed is constant, which is 10 meter per second, right? So for example, here it will be 10 meter per second. Here it will be 10 meter per second, right? Anywhere it will be 10. So this distance is 10 multiplied by this time here t, this time t, so it is 10 multiplied by 0.5, and that is 5 meter. So what is x? This x here, that will be equal to 2.5 plus 5 equal to 7.5 meter. So now if we go back to the problem, and we found this x here is 7.5 meter. So, and we can score 4 points, right? So that was the full detailed solution. Now the final tips: do not lose easy points. See, in the exam you will have some tough problems, and chances are you will not be able to do that, and that's being frank. But if you lose points on easy problems, that's the real tragedy. So to make sure you do not lose easy points, before you start your math, read the problem very carefully. Read carefully, okay? You have to read the problem. Okay? If you do not read carefully and you miss something, then you invest 10 minutes to solve a problem and you will get 0 points, right? So in this problem, you have like the highest point, after splitting, falls vertically, equal parts, right? References like when does the time start and all. Then projectile motion reminders, right? You must, like, before you go to exam, you must have memorized all the equations, right? All of these equations that we talked about here, right? These small things, that how at the highest point the vertical speed is 0, the horizontal speed is constant, these equations, how you apply them, right? What is uy, what is vy, theta is from horizontal. These minor things will make the difference, right? And then at split, understanding that momentum is conserved and you can apply it separately in x and y directions, like here, right? Momentum conservation in x direction, right? In x direction, right? And then in y direction, right? And do not assume that after split the vertical speed is 0. In this problem we were lucky. If you make that assumption, it's just luck, but it could have been the other way, right? If that was not 0, right? And here it is explained why the momentum is conserved, because during the split you have the implosion is an internal force, and during split the time is very small, right? It's instantaneous. So gravity impulse is negligible in comparison to any other impulse, right? So ignore the impulse by gravity. So I hope this has helped you. and I will make more videos in the future.